Hi there. I wanted to talk to you about students using the standard algorithm in school. And to first be clear that the standard algorithm is really good. It's efficient, and students receive a lot of support in school and at home using the standard algorithm. But I want to clarify some misconceptions, and I want to show you how to use the standard algorithm in a friendlier way that is easier, and B, it shows a better understanding of the steps that is happening. And so the kids are more flexible with their mathematical thinking. First, I'm going to show you what we commonly know as the standard algorithm. And I'll show you the confusions in that. So if I'm looking at 54 times 4, we would often start in the ones place value, and we would say 4 times 4. Well, we know that is 16. But we have taught the kids to only put the 6 and then to carry a 1. And that is question number 1. Do they know why they're carrying the 1? And do they know why they multiplied this? And now next, they're going to multiply 4 times 5. And okay, confusion number 2, for the record, that's 5 tens. It is not a 5, but okay. 4 times 5 is 20, but then they are adding this 1. So they're going from multiplication to adding in the same step. And that is also very confusing. But they'll get 20 plus 1 is 21. And they very quickly and easily got to the answer. But if they made any mistakes in this, they would not have the right answer. And it is very confusing. They may not know how to work their way out of this or even what to do. So let's make more sense with our math and make it more flexible with our thinking. I'm going to show you a much easier way. For example, 4 times 4, we just said is 16. Let's just write down 16. Why does that have to be so difficult? As well, before I do the next step, it's very important to note that 5 is not actually 5, it's 5 tens. So the number 54 is actually 50 plus 4. We just took care of that 4 right here. Now let's take a look. This 4 times 5, a better understanding shows it is actually 4 times 50, and that is 200. Now I can add that up, and I have a genuine understanding of what was happening with those numbers. And that way, if the kids make mistakes, they can also reason their way out of it with a better understanding. I bet many of you have seen this happen before, where the students instead of multiplying at the ones, they start here and they start multiplying this way. If we did it over here, that's not going to work because they had to know that they were carrying the 1 first. So this is very inflexible, and it does not show a true understanding of what's happening with the numbers. But if a student came in and started going this way, well, why can't they? If they know that this is really 5 tens, they know their place value, so that's 50. Could they do 50 times 4 and say 200? And then do 4 times 4, 16? It is still the same answer. So that is a very better understanding for them to have, and will lead to much more flexibility later when they are doing different kinds of math. So I'm just going to put a happy face here, a frowny face here, because I don't always understand what's happening here. But this shows us different ways of thinking. Now, I'm going to show you something else that we were learning today. Instead of 54 times 4, we're now looking at 54 times decimal 4. This is what trips a lot of kids up, and we need to have an understanding about that decimal 4 and what it means. So I'm just going to set this aside. I'm going to get out another whiteboard right here. And again, it's very important that first we teach the children 54 times decimal 4. That they know what it is that they're looking for. So in my class, I have been working with benchmarks on partitioning a number line. So they are just going to make a line and they're going to cut it in half. I've also been teaching them other benchmarks, how to make quarters, thirds, eighths, sixteenths, and so on. But for this purpose, we're just going to do half. The first thing to note is that the kids need to be fluent in understanding half. Half can be written like this. It can be written like this. It can be written like this. It can be written like this. Okay, or it even can be written like this. Okay, so it's very important that they know that half is 0.5 on the line. So if we make this value out of 54, can they then reasonably figure out where 0.4 is if they know that this half is 0.5? They can reasonably use that benchmark and say 0.4 would be right about here. So if they know what half of 54 is and they can answer that as 27, then they know that their number is going to be less than 27 and they have a reasonable idea of what they are looking at. That's very important that the students have this ingrained in their heads, if they can always work with those benchmarks with their mental math. They don't actually have to draw it out. Eventually, this will be common sense to them. But if they're at the stage where they need to draw it out, that's what we need to do before we do our math. So now let's take a look at, we know that our number is going to be near 27. I'm going to erase my previous board for comparison. And we first have to look at our place value. Here is another misconception that we often see happening. Students will do 54 times 0.4. I can tell you, this is my red flag right here. They might still get through the math and get the answer of 216, but then the student comes in later and they put the decimal in and they don't know why. It's just a step that they were told to do. So let's have a better understanding of what this should be. No, thank you. That's not how it works. So let's look at our place value. When we are looking at place value, we are looking at, actually, I'm going to write it this way now, at our hundreds, our tens, our ones. Those are our whole numbers. Okay, so these are whole numbers. And then we have our decimal, and then we have tenths and hundredths and so on. Okay, we're not going to get into those other ones. I'm kind of losing room here. But you can see the decimal is what separates our whole numbers from our decimal numbers. So the number 54 is not a decimal number. I'm looking at 54 times 4. 54 is a whole number. So it's going to go in our tens and ones. 54. But 0.4 is not quite a whole yet. It's not at 1.0 on our scale yet. It's still 0.4. So let's put that in. 0 whole, but we have a decimal 4 in our tenths place value. So we know that 54 is like that, 54.0 as well, if the kids need to fill that in. Now we can multiply this out with the same routine that I just taught you. But we need to refer to this as our decimal. So 0.4 times nothing is still nothing. It's nothing. 0.4 times 4. Reasonably speaking, I know that half of 4 is 2, so it's going to be less than 2. But if we say 0.4 times 4, or 4 times 4 is 16, that would be 0.4 times 4 is 1.6. Do you see how my decimals are remaining in line? Now I can look at, remember 54 was 50 and 4. We took care of that 4 right here. So now let's look at our 5 tenths, our 50. So 0.4, half of 50 would be 25. So we know it's going to be near 25, maybe a little less. So 0.4 times 50 is 20. And there we go. Now we can add this up. 21.6 is our answer. So to check the reasonableness of this answer, let's take a look here. We knew that half of 54 at 0.5 was 27, so it would be a number less than 27, but within a reasonable range. 21.6 does fit within a reasonable range, so we can be rest assured that we believe that that answer is correct. I hope that helps.